So we want to graph, when you look at slope-intercept form, so that's y equals mx plus b. To graph an equation, all you need is slope and y-intercept. And y-intercept is where it crosses the y-axis. So it could be also called a starting point in like a word problem. It could be the constant when you're looking at an actual equation. And then y-intercept as far as like looking at a graph where it actually crosses. Your slope, so many terms for slope. So you have slope, you have rise over run would be a way that you'll hear it discussed. Rate of change, which I normally write ROC. So if I ever do that, that's rate of change. Coefficient of x. Is also your slope. So all four of those like terminologies or sentences are all asking for that value that's attached to your x, or how at the rate of change. Obviously, rise over run is a fraction. Your rise is your y, your run is your x. So in this case, our m is going to be a -1. Hopefully we know that there is an imaginary 1 in front of any variable that has no number there. And then our starting point, or our y-intercept, is -2 because it's the constant at the end of the equation. They don't have to be in this order, like mx doesn't have to sit in the front seat and b in the back seat. But more times than not, they are. So we're going to start at -2. And then you're going to go down 1 to the left 1, because as soon as you know negative, this line needs to be shaped this way. So reading from left to right, it's going to go down. 1-to-1 slopes are always my favorite because they're the easiest to extend and pretty much make a straight line, usually. And then you're going to make a straight line. And if you have a problem drawing straight lines, no big deal, but use a straight edge, especially if you're drawing it on paper. Fortunately or unfortunately, being virtual, you're probably going to do more of it online. It's not a huge deal. I think it was your activity today on Delta Math. They give you a little ruler, and it kind of keeps the line straight for you. But the straightness does matter, as I've said 100,000 times. The neatness and how you keep things organized makes a difference in getting that right answer at the end, especially when math gets a little more difficult. So y equals mx plus b again. We need our slope. We need our y-intercept. And then probably we want to decide if it's a positive or negative. So again, an imaginary 1 slope, that's 1 over 1, because all whole numbers have an imaginary 1 underneath it as well. So your run for every whole number will be 1. And then our y-intercept is -4. And we know that our slope is positive, so our line is going to be shaped going up from left to right. So from left to right, it's going up. So we're going to start at -4. It's a 1-to-1 slope again. And that's rise 1, run 1, so that's making those stairs that we've talked about in the past. And if you count the other way, and that's just the way your brain works, that's like down 1 to the left 1, down 1 to the left 1. So we go the other way, down 1 to the left 1. That's -1, -1, which is positive, because negative and negative give you a positive. And then we're just going to connect our line, put arrows on the end, because all these graphs are like a window on your calculator. So we just zoomed in to a portion of the line. But lines are infinite in both directions. So going positively, they're infinite. Going negatively, they're infinite. And that would be your infinity. So on the x to the right is positive infinity, negative infinity to the left, negative infinity, positive infinity. So theoretically, we can infinitely expand this graph and this line because it's never ending. Number 3 on here. So this is our horizontal vertical line conversation, which you will have today if you take your notes and watch all your videos. The easiest way to remember this is Hoy Bucks. So horizontal, 0 slope, y equals equation. This is an x equals, so that's vertical, and by horizontal, that means we're going this way. Vertical goes this way. So vertical, undefined slope, not 0. 0 and undefined are completely different. And then x equals equation. And in this case, it is an x equals, so that means x is going to equal 0. And the other thing I've also tried to get students to do, instead of thinking of equal, thinks x is 0. So if I tell you x is 0, and then I say, what is x when y is 4? Well, I just told you x is 0. It doesn't have anything else with it. It is 0. So no matter what your y value is, x will always be 0. And so x equals 0 is the line of the y-axis. And it's vertical because it's an x equals. Number 4 is back to your slope-intercept form. So y equals mx plus b. And then m is your slope again. So we're going to identify our slope. So -2/3. So that's a rise of 2 and a run of 3. The y-intercept is a -1. So that's our starting point. So we're going to start at -1. And then we know that our slope is negative. So we know our line is going to be this shaped. So going down to the right. So reading from left to right, it's going down. And so -1, we're going to go down 2 to the right 3. So it's -2 to the right 3. -2 to the right 3. And you do want to fill in your graph completely, especially on Delta Math. If you ever have to graph, you want it to be the entire length of this graph. So up 2 to the left 3 is also that -2/3. And then we're going to connect our dots, and that was not exactly straight. Sorry, guys. I looked up, saw some things going on the computer screen. So make sure it's a little straighter than that so it does look like one continuous line. So that's graphing when in slope-intercept form. Now, I put some multiple choice on here because I feel like for some people it gets weirder when I give you a choice. You either love multiple choice or it makes things very complicated, but the game is still the same. So in this case, we're going to figure out what is m, what is b. So our m value, or our slope, or rise over run, is 1/4, rise of 1, run of 4, and our b value is 2. So we're looking for a graph that starts at +2. Well, this is -2, so this answer's out already. And then this is +2, so that's maybe pretty good. This is -2, so this one's out. And this one's a +4, so that one's out. So this answer choice is fairly easy because this is the only one that starts at a +2. And they are counting by 4s, so this 1 to 4 would be that stair step of your slope. So our answer for that one would be B. Number 6 again, so our m is a -2/5, so we know it has to be a negative line. So it's going to be this shape direction. And our b is a -2, so we're looking for a line that's shaded down, like shaped going negatively. This is a positive line because it's going up, so we can get rid of that one. Not to mention it's not going through -2. This is also a positive line, so it's out. Again, it's not passing through -2 as well. This is a negative line, so that's good, but -2 is down here, and up here our y-intercept is a -2, but our graph shows it at a +2. So getting closer, but not on the right y-intercept. The right slope, but not right intercept. Now we have our y-intercept at -2, and it's a negative line, so our answer for this guy would be D. And that would be how I would suggest going through some of your multiple choice questions where you are trying to match an equation to its graph. You just look through each one of them and go very slowly because some of them are going to look very similar to each other. So like I just did, go through them very slow. Y-intercept, slope, positive, negative. Those are the 3 things you want to think when graphing lines. Now, so when we put a graph, some more graphing of lines. So y = 2. Again, this is our Hoy Bucks situation. So it is a y equals, so we know it's a horizontal line with 0 slope. And horizontal, remember, is going this way. Vertical is going this way. And the other way that you can maybe figure this out, so horizontally, that if it's rise over run for your slope, if it's going this way, it has no rise, but it does have some run. So in this case, it would be 2. Your run would be 2. So it's going to hit at that +2 and go this way. And go this way, because y is +2. If you type this in your calculator, it is going to give you 0. For your vertical line, if it had been x = 2, then that would be that there is 2 rise, but no run. And if you put this in your calculator, it's going to give you an error. You can't divide by 0. That's why that undefined slope comes into play for your vertical lines. So number 8 again is a y equals, so that's our Hoy, horizontal line, 0 slope, y equals. So I'm going to go on the y-axis at -5, and then draw a horizontal line, which is going left to right, flat lined, and that would be your line for y = -5. Now, number 9, this is in standard form versus your slope-intercept form. Slope-intercept form is very easy to find your slope and to find your y-intercept as far as putting it on a graph. Now you have choices here. You can either graph this guy the way our lesson is today, if you're on our page when you take notes there, which is not a terrible practice, by isolating your y, which means I'm going to get this guy by himself, your line of great divide, and putting into slope-intercept form, there are like repetitive rules. So number one, find your y, notice what's in front of it, and then we're going to move x. That's the first thing to do. So move x to the other side, so we're going to subtract 3x from both sides. And that's going to give me a negative 2y equals a negative 3x minus 2. And then we're going to divide by whatever's on y. So get y alone by inverse. So we're going to divide by negative 2, negative 2, negative 2. Make sure you treat that negative 3x and that negative 2 as two separate terms and divide both of them by negative 2 because you do want your rise and run for your slope. And ideally, you would like your y-intercept to either be a whole number or a decimal because it's easier to graph that way. So y equals negative and a negative is going to give me a positive. Negative, negative, 2 divided by 2 is going to give me a positive 1. So our slope, again, is a positive 3 over 2, which means a rise of 3, run of 2. Positive means our line is going to be shaped in that direction. Our starting point, or our b value, or y-intercept, is 1. So you're going to start at 1. You're going to go up 3. 1, 2, 3, and over 2. Down 3, over 2. Down 3, over 2. And again, fill in your entire graph whenever you can. And draw arrows on the end. So number 10, I would say every time you see a variable without a number in it for this point, and especially for like your Math 1 EOC, it's just a small little thing that you think you don't need to do, but it'll keep you from making a careless error along the way. And anything we can do to keep from making like silly mistakes is really beneficial because you're going to run into enough that's hard enough that you might make a real mistake. So let's try to keep those to a minimum. So we're going to make that negative 1. We know we have a negative 1 in front of that y because that also makes sure that you don't forget about the negative or lose the negative when it's just sitting out there in front of that y. So again, we're going to move x. Coincidental that these and most of the ones in your notes today are negative 3. This program where I got these worksheets apparently really likes 3x. That is not a real thing in the real math world, that there would be that many of them. But there are today. So we're going to divide by whatever's attached to y. Sometimes if it's a fraction, you'll multiply. You'll see that in today's notes in our assignments. But usually it's a whole number attached to y, and you're just trying to get rid of that. So it would be division. So y equals that negative 3 divided by negative 1. It's going to be 3x. And then 2 divided by negative 1 is going to be a negative 2. So my slope is 3. And we know all whole numbers have an imaginary 1 underneath it. Our y-intercept is a negative 2. So our starting point is negative 2. So we're going to go to our starting point, rise 3, run 1, rise 3, run 1. If you want to go off the graph, it's just 1 off. Down 3, over 1, we're 2 off. Or you can just put arrows out here, it's fine too. And know that it's going to keep going infinitely in both directions. Our slope was positive. So you do want to make sure, because I know for me personally, especially if I'm distracted, that's one thing. Like I know my y-intercept really well. I know how to count my rise and run. But every now and again, I'll get them mixed up when I'm talking or doing something else and graph a negative line instead of a positive line or vice versa. Now, with that said, so if given an x-intercept and a y-intercept, that's 2 coordinates. And all you really need to graph a straight line is 2 coordinates, because then you get a rise and a run, and you can put arrows on the end and you're rocking and rolling. Sorry, I'm coughing again. So x-intercept, that's where it crosses the x-axis. So this is going to be at a positive 5. And your y-intercept, just like before, is a positive 5 here. So that's where it crosses the y-axis. X-intercept, remember, is when y is 0, and y-intercept is when x is 0. That is something that most of you know when we have this conversation, because obviously you can look at it and see it. But if I ask you off topic or in some other random conversation, it's a little tougher for people to remember that x-intercept, because this will apply and help with lots of equations to get things where you need them to be, is also remembering that x-intercept is going to have a y equal to 0, and an y-intercept is going to have an x value equal to 0. So this one we could graph it if you want to count your slope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That can't be reduced, so we're just going to draw a line straight through. Put some arrows on the end. And the reason I say could it be reduced is you may be able to put a dot in between those to help make your line perfectly straight and more accurate. So speaking to your x-intercepts and y-intercepts, in this standard form, you could solve for x and y-intercepts as well. In this case, your y-intercept is going to be ugly. It doesn't come through a great point. But if I plug in your x-intercept, yeah. If I plug in a 0 for x, so 3 times 0 minus 2y equals a negative 2. I can solve for y and find my y-intercept. So 3 times 0 is going to give me 0, so that's gone. Divide by negative 2, y equals a positive 1. So that could get you started on some of them as well if you know you're not really great at isolating y. So then I have my y-intercept at that positive 1. And like I said, your x-intercept is not going to be quite as neat. So 3x minus 2, and that's where you plug in your 0 for y. So this goes away. So it's going to be 3x equals a negative 2. Divide by 3. So it's a negative 2 over 3, which is less than 1. So I would change this to a decimal for my graphing on a number line, which I think is 0.6 repeating, if I'm not mistaken, if I remember correctly. So it's about 2/3 of the way over until you get to negative 1. So we could graph those two. In this particular one, that's not going to give you a whole lot of information. It's probably a much better line by isolating y, but it is an option. But you would need to do it for both so you get those 2 points. So 12. My x-intercept is negative 4, which again means that y is 0 for that point. My y-intercept is negative 5, which means x is going to be 0 there. So I'm going to go over to negative 4, not go up or down, not going to go up or down, and then I'm going to go down to negative 5. And then I have a line again. And both of these just happen to be negative lines. Again, that's more coincidental than anything else. If you want to check and see if our 1, 2, 3, 4, 5, 1, 2, 3, 4, so it's a 4 by 5 slope. It is not reducible, so that's all you can do. If I happen to have a bigger graph, you could go on up 5 over 4, up 5 over 4, and keep going and extend that line if it was a little bit larger in the graph size or if the slope was smaller. All right, so writing equation in slope-intercept form when giving those fancy little parts. So it's much like even graphing it. You could graph it given the y-intercept and the slope. That's what we took away from the equation. So if given this information, you can answer tons of questions. So in this case, if we put it in slope-intercept form, y equals mx plus b, we know that slope is m, y-intercept is b. So this is going to be y equals 1/4 x minus 2. Because the y-intercept is a negative 2. If you put plus a negative, that's okay, but pay attention to the different formatting. If it was a multiple choice question, remember adding a negative is the same as subtracting. So usually when it's a negative, you're just going to see minus, not plus a negative. But I value and validate both are correct mathematically. It's just the formatting of said question or said website or thing that you're using. So I'm pretty sure, if I'm not mistaken, delta will take either one. But I would, if you can, probably do it this way because that's really hard to argue. The other one's the only one that I've had people go, that's not correct, which it is, but it's just different format. Okay, again, so slope is m, y-intercept is b. So y equals mx plus b, and then we're just going to plug in. So y equals, our slope is 1, x, and our y-intercept is 3. Now, I cannot reiterate or say this enough. Y equals mx plus b. Y has a job, x has a job, slope has a job, and y-intercept has a job. So they are all four very different people, very different letters, variables, jobs. When I ask for the slope, so in this case, I've had many students tell me the slope is 1x, but that's not the answer. The slope is 1 because x is a point. X and y is a coordinate that happens on the line anywhere. All the points that make up a line is what x and y are. So they have a different job than to actually describe the slope. So when discussing slope, again, you are only using your m value for that answer, not m and x, because x, again, is a different conversation. So say you were on campus or your mom asked you to come and talk to her, and all of a sudden you grab your brother or sister and go with them. She didn't necessarily ask to talk to your brother or sister, so you don't need to bring them with you. Same as the conversation of the x with the m. They're separate. It's two different conversations and jobs, per se, in this case. So an ugly slope of a -7/3. So this is our m, It's our b still. So again, y equals mx plus b. So y equals our slope, x after it, plus 3, because our b is 3. And then number 16 again is our slope, which is just our m value. Y-intercept is going to be our b value. We have y, our m is negative 4 over 3, x, and then plus b, just going to be plus 5 because it's a positive 5. So that's writing the equation when given the slope and the y-intercept. Now, if you're given a graph, you're still doing the same thing. So we can find slope, which you know is our m value, and then our y-intercept, which we know is our b value. So our slope, I actually would probably find your y-intercept first, because you know that's going to be a good intersection usually, especially if it's this type of question. So we're going to look on our y-axis and find that our line in this case touches at 1. So our line's going to touch at 1, so our b value is going to be 1. And then we need to find another good intersection. I have had students that have a really hard time figuring out what those intersections are. So if you are looking for exactly where the coordinate grid crosses. So this is not at a cross, this is not at a crossroad, this is not at a crossroad. This is a good intersection. So if you're thinking about like downtown Southern Pines or New York City or anywhere that has a gridded kind of city map, you are standing on the corner, not in some like backyard, front yard, doorway, like dead on the corner. Or actually, I guess in this case, you'd be standing in the middle of the intersection where the stoplights are and arguably going to get hit by cars. So don't do that. But that's what you're thinking when you're looking for a good one. So there's not a good one here. We're still somewhere on a street, in a yard, somewhere on a street. Now we're standing underneath those stoplights, so that's a good intersection. So we're going to count our slope. So 1, 2, 3 up, 1, 2, 3, 4 over. 1, 2, 3 up, 1, 2, 3 over. So rise 3, run 4. And again, as in our discussion when we were first started slope from your graph, you don't want to count it once. And that's because, again, you may pick an intersection that looks good, but it's actually not. Or you may count wrong by accident, and you need that pattern to repeat a minimum of 2 times. 3 times is when you know you're in there, like solid, got the right slope. So it's a rise 3, run 4. This is a positive line going up to the right, so we know that our slope is positive. So when we write our equation now, y equals 3 over 4 x plus b. Everybody doing okay? Any questions? I feel like we're going to finish really fast. Nobody's asking anything or typing in anything. All right, so number 18, we're going to look for our slope and our y-intercept. So we're looking for where it crosses the y-axis. So we're going to go up and down our y-axis, which is your vertical axis. Up and down, and there it is at negative 4. So our y-intercept is negative 4. We're going to look for a good intersection. So x-intercepts are awesome, usually. If they cross through a good intersection, that's great. And then we have another one up here. Again, we have a positive line, so we know our slope is going to be positive. So 1, 2, 3, 4, 1. We need to make sure it happens again, that 4 by 1. And then 1, 2, 3, 4, 1. 4 by 1. So it looks like our slope is a positive 4 over 1. And in our slope conversation on our first day, this is correct for rise over run. So if the conversation or question was, what is the run or what is the rise, you do need that fraction. But know that every whole number has that imaginary 1 underneath it. And it's usually just assumed. So we'll just put 4x minus 4 and leave off the run part in that case because it is that 1. I'm going to pause for a second and see if you guys can hopefully, and if you can't see it, let me know. Actually, I probably can zoom in too as well. Let's try and see if you can write the equations for number 19 and 20 from the graph right now. Get us in a little closer for you guys. Oh yeah, way closer. All right, so you're writing 19 and 20 for a second. I'll give you until it's 10, 12 maybe. See if anybody can write it down on their piece of paper, scratch piece of paper. That way you can see if yours matches mine. Today's the day to mess up, not on quiz day. So looking at number 19, we're going to look for our slope and our y-intercept. So where does it cross the y-axis? At a -3. We're going to look for another good intersection. There's a great intersection right there again at the x-axis. Another one up here a little bit higher. And it looks like it goes off the graph and off the graph, so that's all we're going to get. And you're going to count between those dots. So 1, 2, 3 over 1. 1, 2, 3 over 1. So it's a rise of 3, a run of 1. So our slope, again, is 3 over 1. We're going to leave that as a positive 3. So y equals 3x minus 3. And that means the slope is 3, your y-intercept is a -3. The questions they could ask, is this a positive or negative line? It is a positive line because your slope is positive. What's the constant in the equation? It would be -3 because it's the number without the variable. The leading coefficient would be 3 as well because there's a 3 in front of that x. The coefficient of x would be 3 because that 3 is attached to x. Your slope, again, is 3. Your run would be 1 imaginary because you don't see it underneath that whole number. I'm trying to think of all the different types of questions they could ask you. In this case, what is your x-intercept would be a fair question because it's right there on the graph. And that's just that this guy right here is your x-intercept. So that's that 1, 0. And again, your y-intercept as a coordinate, x will always be 0. In this case, it's that -3 because you didn't go left and right if you're going to be traveling along the y-axis. That's why x will have to be 0 for every y-intercept, and vice versa for your x-intercepts. Hopefully you're able to see this line. It is a horizontal line. Horizontal line. She's going this way. And if we remember Hoy-Vux, the Vux part does not necessarily pertain to our conversation right now. So it's going to be a 0 slope. Whoops, I'm off the screen, sorry. 0 slope and a y equals equation. So y equals, and in this case, you just have to tell me what y equals. And so that's a -3. And you have now written the equation of a horizontal line that crosses through the y-intercept of -3. It does not have an x-intercept because it is a horizontal line. And it does have a 0 slope. For the most part, that is going to be it as far as your graphing and the expectations for your lesson today. Any more questions, guys?